So properties of exponents today, section 1.5. Again, this will not be on the quiz tomorrow. So we do have an assignment today. That will probably be due on Wednesday, unless we have time tomorrow after the quiz. Then we will check the assignment then. This is really a lot of review from Algebra 1. Again, remember me talking about Algebra 2 is really Algebra 1 on steroids. In Algebra 1, this section would take you about 5 days, or about 5 different sections. In Algebra 2, we covered all in just 1 day. So it kind of just, again, talks about how the difference between the two classes. But properties of exponents should be a lot of review, and as we start going through it, hopefully you see that it is a lot of review here. We do have all these properties. Okay, the first one here, 0 as an exponent. Every one of them starts off for every non-zero number. You don't need to write that down. The important part is writing down, this property right here. And we talked about that last week. I think we had a warm-up problem with that. We had a number to the 0 power. A lot of us were saying, oh, that's 0, or that's the number itself. And then we remembered, no, anything to the 0 power is actually 1, okay, except for 0. But any number, any non-zero number raised to the 0 power is always going to be 1. Doesn't matter. I could have the largest number ever. I could have the number 85 to the 0 power. Doesn't matter what I have, anything to the 0 power will always give me a number of 1. Okay? Negative exponents. Last week we talked a lot about different things of how you have to express answers in math. In radicals, you can't have a denominator in the denominator. Can't put a negative associated in the denominator. Well, with exponents, we do not want a negative exponent. Okay? So a to the negative n power becomes 1 over a to the n. Essentially what happens here is when you have a negative exponent, you have to either move it to the numerator or denominator, whichever one it's not in order to express it as a positive exponent. Okay? So an example here would be, if I had a to the negative third power. Well, a to the negative third power would become 1 over a to the third. Okay? It's a negative exponent in the numerator or by itself there, so I have to move it to the denominator to express it as a positive. Now, the one that a lot of students struggle with is if it's in the denominator. So let's say I have 1 over b to the negative second. It's negative in the denominator. I now need to move it. I'm going to put it up in the numerator and make it positive. Okay? The biggest thing is you cannot have a negative exponent. We do not want to express anything as a negative exponent. All right? Next one here. Multiplying powers with the same base. For every non-zero number a and integers m and n, the shortcut here is to say when you're multiplying exponents and they have the same base, the shortcut is to add the exponents. Okay? Now I say that this is the shortcut because you can always go through the long way of understanding these just by understanding what is an exponent. Okay, so if I were to look at this and I said a to the m, let's make that x to the third. Okay, a to the n, let's make that x to the fourth. Okay, now the shortcut tells me that is really just going to be x to the seventh. 3 plus 4 gets me 7. But why does it get us x to the seventh? Okay, here's why. It all comes back to understanding exponents. X to the third, it really is x times x times x. All that can be expressed as x to the third. X to the fourth is really expressed as x times x times x times x. All that is x to the fourth. When I multiply all that, I can kind of see as I list out, I have 7 different x's, or I get x to the 7th. So just kind of having that understanding of what an exponent is will help get you there. Okay? Next one here, raising a power to a power. Okay? Again, as it starts out, for every non-zero number a and integers m and n, anytime I have a power to a power, you need to multiply. Okay? So the shortcut there is to multiply. This is a lot like kind of distributing. Okay, I associate this a lot to distributing. Anytime you see a number on the outside parentheses, what do you always think? Distribute, right? Well, if I have an exponent raised to exponents on the outside, I'm going to distribute or multiply that exponent to the inside. Okay? Example of that would be, if I had x to the third all to the fourth power. Well, the shortcut tells me that's going to give me x to the 12th. Okay? If I wanted to go the long way and look at this, well, x to the third to the fourth is really just x to the third times x to the third times x to the third times x to the third. Exponents, how many times I listed out. If I list it out 4 times 3 plus 6 plus 9 plus 12, I still get x to the 12th. So this all comes from just understanding what an exponent means. Okay? And then raising a product to a power, very similar to this. Okay? You would take that power to all the powers on the inside of that parentheses. Take that power to everything on the inside. Okay? Last one. The second one's very similar. The first one, well, if when I multiply, I add exponents, it makes sense that when I divide, I subtract exponents. Okay? Opposite operations there. So when I multiply, I add exponents. When I divide, I subtract the exponents. So I can look at the same exponents again. X to the fourth over x to the third would become x to the first, or just x. Okay? And we'll look at some problems there later. The quick way is to always look at where is the exponent larger at, and then subtract from there so we don't deal with negative exponents. And we'll look at a few of those in our examples. But again, when you multiply, you add. When you divide, you're going to subtract exponents. And then raising a quotient to a power, just like raising a product to a power, when I have parentheses, you distribute that exponent to everything on the inside. That's really nothing new there. It just shows you for a quotient as well. Very, very similar to the power product. Again, a lot of different properties, and each one of those would have been a different lesson in Algebra 1. And here in Algebra 2, it should be a lot of review, hopefully, for a lot of us. Do a lot of us remember seeing this in Algebra 1, hopefully? Yeah. Okay. So, should be a lot of review here. Alright, so number 1. I have 4 to the negative third power. Okay? I don't like negative exponents. Shane, how can I rewrite this so I don't have a negative exponent? I have to move it. So 1 over. Very good. Now, because it is a number that we can express, I will want to find out what 4 to the third is. So 4 to the third would be 4 times 4 times 4, which is what, Justin? Very good. I get 1 over 64. Okay, and there is 4 to the negative third. 3 to the negative fourth. Again, I don't like negative exponents. How could I re-express that, Sage? 1 over 3 to the fourth. Does anybody know what 3 to the fourth is?
81.
81. So 1 over 81. And again, recognize, negative exponent does not mean a negative answer. A lot of times students get confused and want to express their answer as negative terms. Negative exponent just means fraction. I have to change where I'm writing it at. Number 3, negative 7 to the 0 power. Colin gets me.
Is it just 1 over 7 to the 0 power? 1.
So what's the answer?
1.
1. Yep, negative 7 to the 0 power would be 1. Now, recognize difference here. If I had negative 7 without parentheses to the 0 power, does anybody know what that would be expressed as? Negative 1. Because there's no parentheses, that would be expressed as negative 1. Okay, because that's 7 to the 0 power, and then you tack on the negative. So recognize when there's parentheses, when there's not parentheses, there's a difference. Number 4, very similar to number 1, negative 4 to the negative third power. How would I express that as an answer, Garrett? How could I rewrite it first?
What?
How could I rewrite that first?
1 over negative 4 to the third.
Okay, 1 over negative 4 to the third. Okay, now we already figured out 4 to the third was what, Colin?
64.
So how would I rewrite this?
1 over 64. Negative 64.
Okay, now do we associate the negative in the denominator?
No.
Either tack it on out front or put it back in the numerator. Okay, but negative 1 over 64 would be correct there. Again, don't want negative exponents. No negative exponents, 0, get us 1. Next part here. We're going to keep progressing through these. Number 5, I have x to the second times x to the fourth. I'm multiplying. Okay, if I'm multiplying, what am I going to do with my exponents, Jack? I'm going to add them. What do I get?
6.
X to the sixth. Nice job, sir. What about number 6 here? If I have a to the fourth times a to the fifth, what would I get, Reagan? A to the ninth. Nice job. Number 7, y times y to the fourth would get me y to the what, Phil? Y to the fifth. Nice job. A lot of students will want to forget there's a 1 there. Okay, 1 plus 4 gets us the y to the fifth. Now, 8z to the 0 power times z to the 8th. Don't make this harder than what it is, because the answer is what, Sean? Z to the 8th. Okay? Yeah, 8 plus 0 is still 8. Or you can think about it as z to the 0 power is 1. So 1 times z to the 8th is still z to the 8th. So it's that identity property. Next part here. Getting a little tough for now. You're going to keep progressing through. We're going to simplify these expressions. Okay? X to the fifth. And then I have parentheses, x to the second to the fourth power. I have this power raised to a power here. Okay, and I think about it as parentheses with exponents. I want to do that part first. Take this step by step, and these problems do not have to be difficult. So what is x to the second raised to the fourth power going to get me, Garrett?
X to 6.
I need to multiply.
Oh,
So I get x to the fifth, x to the eighth. X to the fifth is that first part, right?
Yeah.
So x to the fifth times x to the eighth. Take this step by step. Now I'm going to add my exponents, and I get x to the what, Reagan? X to the 13th. Okay, and again, take this step by step, and these problems do not have to be overly difficult. That would be, yes. Number 10. Yes, sir.
Wait, how did you get 8?
How do I get 8?
You multiply the 2 and the 4.
Yep, because it's a power to a power. So number 10 here, same kind of setup. I have y to the second, parentheses, y to the second raised to the negative fourth. Okay, that power raised to a power tells me I'm going to do what with the 2 and negative 4, Sage? Multiply. So I get y to the second, y to the negative 8th now. Okay. Now I can add my exponents. 2 and negative 8 are going to add to get me what, Justin? So I get y to the negative 6th. However, I don't want negative exponents. I want positive. How would I rewrite that, Justin? 1 over y to the 6th. Nice job, sir. All right. 11. I have 2 powers, or 2 exponents raised to an exponent. I have a to the second to the third times a to the third to the 5th power. Well, a to the second to the third power is going to get me what, Phil? A to the 6th times a to the third to the 15th, or sorry, a to the third to the 5th power will give me what, Ethan? Three times 5 is, because it's a power raised to a power, I need to multiply. So we get a to the 6th times a to the 15th. Now I'm going to get a to the what, Andy? 21st. Okay, so again, problems like these, don't try to do it all in one. Take it step by step, break it all down, and yeah, you can combine them quite easily. 12, x to the third times x to the second raised to the negative third. X to the second raised to the negative third would get me Mark, is it right?
Yeah.
Where do I get there?
Negative x to the 2.
Yep, so second to the negative third power would give me x to the...
Negative 6.
Nice job. So x to the third times x to the negative 6 gets me what then, Mark?
Negative 3.
And we don't like negative exponents. I would now express that as
1 over x to the 3rd.
nice job, sir. Again, take these step by step. Not too bad. Next part here. Okay, these are the ones that students kind of struggle with the most. And the exponents we get, it's because we start throwing numbers in there. Okay, we start throwing some numbers in there, and we kind of forget what to do. What is the exponent associated with that 2, Garrett? The exponent associated with it is a?
Wait, 2x?
That 2 right there. What's my exponent there?
0.
If it was 0, I would get 1. So my invisible exponent is actually a 1. Very good. Yeah. Remember, if it doesn't have an exponent, the invisible exponent is always a 1. So when I raise my product raised to a power, I need to remember we said it's just like distributing. I'm taking the 4 times my exponent, not times the number. I want to times it by the exponent. So when I do that here, I get 2 to the 4th x to the 8th. I get 2 to the 4th because I get 4 times 1, 2 to the 4th. 4 times 2, x to the 8th. Now I can simplify. 2 to the 4th power would get me what, Jack?
8.
2 to the 4th power? 2 times 2 times 2 times 2. 2 times 2 is? There we go. 16x to the 8th. Again, the biggest mistake students want to make here is they just want to take the exponent times that number. Okay? And realize we're taking the exponent to the exponent. Try the next 3 on your own there. Alright, let's start walking through these. Number 14. Jarrett, what do you have for an answer number 14?
9x.
Nice job, sir. 9x to the 6th is correct. Number 15 might have been tough. We had a negative exponent on there. Andy, do you have the answer number 15?
-64 times 1.
Close. That is not it, though. It's close. Sean, do you have it?
I had 1 over 64 y to the 12th.
That is correct. 1 over 64 y to the 12th. Again, remember, negative exponent does not mean negative answer. Does that make sense, Andy? Okay, and we have the 64 correct, so I could distribute it, or I could think about it, let's just move it to the bottom right away, and I get 1 over, 4 y to the 4th to the 3rd. Okay, you can, a lot of different ways to do these problems. You can distribute the exponent first, you can move it because it's a negative first. Either way, you get 1 over 64 y to the 12th. Okay, number 16. There's just one negative part here. It's the x associated there. What do you get for an answer there, Garrett?
Would it be kind of the same as 10 and 15?
Kind of, a little different though.
75 and then 1 over x to the 6th.
I agree with your x to the 6th.
Okay. Oh, so
5 to the 3rd power is not 75 though. 5 to the 3rd power is actually 125. 125 over x to the 6th. And again, we have to move just the x to the 6th because when I distribute my exponents there, I get 5 to the 3rd, x to the negative 6th. I only want to move that negative part. So I only move my negative exponent. If it's positive, I'm going to leave it right where it's at. Everything's fine. Just move the negative exponent. Okay? Next one here. Yeah, I know, a lot of examples. Sorry, I just want to make sure we hit all the properties. 17. Okay, 17 here. So I have x to the 5th over x. Oh, whoever's trying to tap in here is going to make... Okay, so number 17. X to the 5th over x. What is the exponent in the denominator there? Sage, what's the exponent with the x in the denominator? What's the exponent in the denominator? This x right here, what's the exponent? 1. Because I'm dividing, I'm going to subtract exponents. X to the 5th over x to the 1st gets me x to the what? Shane?
X to the 4th.
Nice job, sir. X to the fourth. Okay, good work. Now comes number 18. Okay, y to the negative third over y to the fifth. Now, we're dividing, so we do need to subtract exponents. However, on problems like this, students, look for the exponents that's larger. Which one is larger? Y to the negative third or y to the fifth? Y to the fifth. So when I want to subtract them, I want to subtract them in the denominator. Okay? So 5 minus a negative 3. 5 minus a negative 3 actually becomes a plus. 5 plus 3 is 8. It was larger in the denominator, so I'm going to keep it in the denominator. I get 1 over y to the 8th. Okay? Now, I tell you to do it that way because it kind of eliminates a step. If you do it the other way, y to the negative third minus 5, well, I can get y to the negative 8th. But then again, I have to move it back to the denominator again. So always just look, where's the power going to be larger at? Because that's where my expression will always end up. Okay? Number 19, x to the third, y to the second, x to the negative fourth over x to the negative fourth, y to the seventh. As I look at my x's, okay, is my x's larger in the numerator or denominator? Garrett, is x to the third larger or x to the negative fourth? So I know my x is going to have to stay in the numerator. Okay, just subtract it. It's going to have to stay up there. I have y to the second, y to the seventh. Which one's larger, Justin? So I know my y is going to stay in the denominator then. Just by looking at that, I can see when I move stuff around, this is where it's going to stay. So 3 minus a negative 4 gets me x to the what, Justin? 7th. Good work. And then y to the second over y to the 7th. 7 minus 2 gets me y to the what, Justin? Y to the 5th. So again, looking at this and having an understanding of where the exponents are larger and where it's going to end up can help kind of eliminate a couple steps. And then number 20. 1 over x to the negative third, x to the negative fifth. Now, a couple different ways to look at this. You can say, oh, they're both negatives. I know right away I have to move them where, Bailey? To the top. So really that becomes x to the third, x to the fifth, which gives me an answer of what, Bailey? X to the 8th. Nice job. You could have also added them in the denominator. You get x to the negative 8th and then moved it, and you still get x to the 8th. Again, the biggest thing here is a lot of different ways to work these problems out. Find a way that works for you. All right, last one. Try these 4. Yes, sir. X to the 12th is correct. Okay, take this negative. Take the exponent up top. You get x to the 6th over x to the negative 6. Now I'm subtracting 6 minus a negative 6 to give me plus. 6 plus 6 is 12. Or you can move the negative first, move it to the top. 6 plus 6 is still 12. You get the answer. Number 22, what do you have, Phil?
X to the fourth.
X to the 4th. Nice job. Now realize on this one, this x on the outside is not on the parentheses. So you do not have to distribute that exponent to it. So that's going to be x to the 1st, x to the 8th, over x to the 5th. Okay, so realizing that 4 doesn't have to go to that x. It's not in the parentheses. All right. 23, Reagan, what do you have there?
27 over y to the 11.
Did you have 27 over? How about 1 over 27 y to the 11th? Because I'm taking the exponent to the 3 as well. So it's 3 to the negative 3rd, y to the negative 6th over y to the 5th. That 3 to the negative 3rd, I have to move it to the denominator. So I'm moving everything down to the bottom there. Getting 1 over 27 y to the 11th. Okay. And then the last one, 24. How would that simplify, Garrett? Okay, let's look at just the x's first. I have x to the third over x. What's that going to become, Justin? X to the second. I have y to the negative fifth. Do I like negative exponents? It's negative in the denominator. Where's it going to go, Colin? So I get x to the second, y to the fifth power, and I'm done. Down comes x to the second, y to the fifth. Okay, and again, it's just kind of looking forward. We don't want negative exponents, looking to combine what we can. Okay? Here is your assignment.